Hello, everyone. This is Matt Menifee, and this is my progress report number 4. And this week I was focusing on the time series data and time series analysis for each of the stocks that I had chosen. So I focused on checking for a few different things in the data and forecasting at the end. So let's go ahead and jump in. Okay, so again, this week I focused on the time series analysis. I used the Dickey-Fuller test to check for stationary data. I use logarithmic transformations if it's not stationary so that we can make the data stationary. I discuss a little bit of stationarity. I use an ARIMA model, forecasting with that ARIMA model, and then I do a one-step forecast with the LSTM models from last week. So let's go ahead and take a look. So with this particular week here, these are the original graphs, only that I have added rolling means to the time series graphs. We can definitely see that this data, just from taking a look, is probably not stationary because we don't have data that has a stationary average mean. So the red line here is the average, rolling average mean. I've got the standard deviation as the black line as well. And we can see in each one of the graphs for Cisco Systems, Southwest Airlines, Duke Energy, which actually looks more stationary than the others, just from this graph here, but probably is also not stationary. And then we have JP Morgan Chase, which is also probably not stationary, looking at the graph with the rolling mean and the standard deviation. So the next thing that we use here is the Dickey-Fuller test to test the null hypothesis that a given data set is stationary. We can see from the p-value from each one of these that they're probably not stationary. Actually, the Duke could be considered stationary, though it is getting to the point where we may still want to use the translation anyway. But we've got Cisco Systems, JP Morgan Chase, and Southwest Airlines that all look like they are not stationary here, and we should probably do some adjusting to the data. So using a logarithmic transformation for the data set, we can see that the data does become more stationary. We can take a look here at Southwest Airlines, which still looks probably not as stationary as the others as well. And I'm curious if that's because of the coronavirus data at the end of this set, that the Southwest Airlines saw a major drop. But we can see here that there's a lot of variation in this set. Taking a look at each of the other data sets, though, they do look like they qualify or meet the stationary standards. And to double check this, we can use the Dickey-Fuller test on the transformations as well, which is what I did in the next section here. So just taking a quick look at each one of these, they all do meet the standards for stationary data. This right here, this last one over here, is for Southwest Airlines. This was the this one is stationary, but is still pretty high. Making an adjustment for that, maybe doing a weighted average would help out. But moving on to the ARIMA model here. The ARIMA model, or the autoregressive integrative moving average, is a function that's used to explain time series based data on the on the past using its past values. If there is seasonality in a time series data set, then we want to use the seasonal ARIMA model possibly instead. And the data for this particular case, so we can fit it to the model, does need to be shifted. So there is a little bit of lag that is accounted for in the model. So in this particular case, this is the graph of the shifted logarithmic data sets. These all look pretty great and are all definitely stationary. So here was a check for seasonality. So we break down a lot of the all of the data here into trends, seasonal, residual data, and we base that off of the original data. And so we can see in some of these models that there probably is some seasonality year over year. And so we would use the S-ARIMA model. Here are the other graphs that were created for this particular set. Again, we see some pretty consistent trading patterns, seasonal trading patterns. It looks like through 2010 to 2011, it goes up and then back down from 2011 to 2012. But it looks like more annualized seasonality for each one of these sets. Now, this one's a little bit more interesting. This is Southwest Airlines, and this one probably has much more seasonality in the trading patterns, and that's probably because of the times that people actually go traveling a lot more. I would assume that that's probably what is causing there to be more trading. The stock prices go up as more people travel and the company makes more money. So around the holidays, we probably see a spike in the trading for these airlines. So in order to determine how best to fit the ARIMA model, we need to determine the P, Q, and D values that we can plug into the model. And these can be determined by graphing the autocorrelation and the partial autocorrelation functions. And so for these particular models, just right where we see the graph pass 0 for the first time is a pretty good indicator of where we would have our P and D values here for these models. So in this particular case, it actually just looks like for all of these, this was around 1 for each one, just looking at the graphs myself. So I chose 1 for each one of those. So I had 1, 1, 1 across the board for my P, Q, and D values on these particular models. So the RSS models here, these show how well the model was fit to the data. And in this particular case, they all fit really well. So I wasn't too worried about there being a problem with the forecasting. So the smaller the number, the better the fit. This could possibly be, there could be maybe some overfitting on this. That could be why I got like a result here of an RSS of 0.375 on one of the stocks here. That was actually Duke Energy, which had the best fit out of all of them. So I think that's probably, it could be due to overfitting, but it's really low, surprisingly low. The RSS for these other ones are closer to 1, which are good fits. So here, this is the data being forecasted with the ARIMA model. The orange line is the closing price, and the forecast, this is within a 95% confidence interval. And this it's a little small. It's a little small because it's a pretty big data set. It's all the the day trading values of the stock from 2010 to 2020. So it's a 10-year time frame on a daily basis, which is pretty big. So there were a lot of data points in this particular model, which makes it kind of hard to read here. These particular graphs, I plan on just creating a blown up image of maybe the end, so I can focus a little bit more on the actual forecast. But these particular models seem to be performing pretty well. The last step thing here, these are one-step predictions using the LSTM models from last week that I created. And these were actually surprisingly accurate. This right here was Cisco Systems. This was Southwest Airlines, the $33.76. Cisco System was $45.27. That was Southwest, 33. And then the $79.92, that was Duke Energy, and JP Morgan Chase was $85.34. And these were actually only a few dollars off from the actual closing prices from the 13th. So the 10th was the last data point. The 10th of July of 2020 was the last data point for each one of these data sets, and that was a Friday. So the next trading day was a Monday, and the closing prices for each one of these stocks was actually, these were lower than, they were predicted lower than what they actually closed on Monday. So only by a few dollars. So these, the LSTM model was a pretty good forecaster as well. I would like to experiment with it some more and see if I could do a 30-day forecast with the LSTM model and then apply that to my sentiment analysis to classify these particular stocks. So just a few more steps here till I am finished here with this project. Thanks everyone for tuning in, and I hope everybody's doing really well. Thanks very much. Bye.